Derivative of a function of a real variable in mathematics describes the sensitivity of the function result output values to change in its argument input value. Calculus use derivative as a fundamental technique. Derivative can be used to find rate of change of value, finding maximum and minimum of a values, find profit and loss in a business, to determine the conservativity of a function and whether the function is increasing or decreasing. Derivative can be used in other fields such as healthcare, engineering, and economics. The notion of derivative evolved through time alongside concepts like extrema, tangent, area, limits, continuity, and function, and it interacts with these concepts in an unexpected way. The calculus was created separately by Newton and Leibniz in the latter part of the 17th century. A derivative, in the sense of tangent line, is an ancient idea that Greek geometers such as Euclid, Archimedes, and Apollonius of Persia were familiar with.
Hi, my name is Nushaira binti Muazzam and this is our problem statement. So let's proceed to our question. After graduating from UiTM, Nabila, Aina, Shahira and Farid were accepted to work as engineers at Mega Bina Company. As new staff, we were assigned to build water tank for the use of the staff company. We have decided to construct a closed cylindrical tank that has a volume 100 per cube. The material for the top and bottom of the tank costs 2 ringgit per meter square, while for the curved side, it costs 3 ringgit per meter square. And we need to find the dimension of the tank that minimizes the cost of the tank. So this is our method that we use. First, we draw a picture of the physical situation. Next, we equate an appropriate formula to the given value. And we write S as a subject and naming it as equation 1. Then, we write another relevant formula and naming it as equation 2. Move on to the next step. We substitute equation 1 into equation 2. After that, we find dc over dr, and then when dc over dr equal to 0, find the value of x. And lastly, we find d2c over dr2.
In order to determine the minimum cost of the cylindrical tank, first, we use the given volume, then we write H as a subject and name as equation 1 as follows. Volume V equal to 100 meter per cube, pi r squared H equal to 100, H equal to 100 per pi r squared. Next, we use the other formula, which is the surface area, related to 3D cylindrical shape, and we find the cost formula based on the surface area. Then we name as equation 2 as follows. S equal to 2 pi r squared plus 2 pi r h. C equal to 2 times 2 pi r squared plus 3 times 2 pi r h. And then we got 4 pi r squared plus 6 pi r h. Next, we need to differentiate C to get dc per dr. After we differentiate C, we got 8 pi r minus 600 r, the power of negative 2. After that, we need to find the dc per dr. We need to find the value of r. To find the value of r, we need to dc per dr equal to 0. So, dc per dr, which is 8 pi r minus 600i, the power of negative 2, we need to equal to 0. If we get 8 pi r minus 600 per r squared equal to 0, and then 8 pi r equal to 600 per r squared, r cube equal to 600 per 8 pi, r cube equal to 75 per pi. So the value of r is 2.88 meter. To get the cost, we need to find the d squared c per dr squared. So from the dc per dr, which is 8 pi r minus 600 r to the power of negative 2, we need to differentiate dc per dr one more time. So we get the d squared c per dr squared, which is 8 pi plus 1200 r to the power of negative 3. And then when the r cube, which is 75 pi, we need to replace to the r in the equation. It will become 8 pi plus 1200 per 75 per pi. So it will get 24 pi. We need to replace to the r in the equation. So it will become 8 pi plus 1200 per 75 per pi. So it will get 24 pi. C equal to 4 pi r squared plus 600 per r. We need to substitute the value of r to the value that we get just now, which is 2.88. So we need to replace the r to the 2.88. So it will be 4 pi bracket 2.88 bracket squared plus 600 per 2.88. So for the cost, we get 312 ringgit and 56 cents. That's it, the last answer.
So next is conclusion. The conclusion for this project is differentiation can be used to calculate the minimum cost of the tank. It is proven by the formula we used to solve our problem. We use the cylinder's volume and surface area together. The cost is divided by the radius at the rate of 24 pi. We got Rm 312 and 56 cents for the cost by putting the value of R into the formula cost. We can conclude that link rate problems involve a large number of expressions, some of which represent quantities and others which represent rates, some of which are changing and some of which are stable. It is critical to comprehend the meaning of all expressions so that appropriate values can be assigned. So that's all from us. Thank you.